Join me guys, let's solve this problem together. This is an exercise that was posted by one of our fans. Let's just run through it together. It says, if the stress on a wire is 10 raised to power 10 Newton per meter squared, and the wire is stretched from its original length of 10.00 centimeter to 10.05 centimeter, determine the Young's modulus. Let's sort out the parameters one after the other. We are told that the stress on the wire, as given in the question, is 10 raised to power 10 Newton per meter squared. There is a change in length from the original length of 10.00 centimeter, let's call it the original length, initial length L1, to a final length L2 of 10.05 centimeter. To determine the Young's modulus, let's represent the Young's modulus as letter E, the symbol we're going to use for Young's modulus. Question mark, that's what we're looking for. To start, let us recall the formula for Young's modulus. Young's modulus E is given as stress divided by strain. You can call it the tensile stress or the longitudinal stress divided by the strain, because the stress is used in stretching long sideways. It's a tensile kind of stress, right? We are given the stress in the question as this, which means we know that, but we do not know the strain. However, we have parameters that can help us determine the strain. So to calculate for the strain, let's start by calculating the extension produced. The extension produced is the difference in the length. So the change in the length, which is the extension, is the final length minus the initial length, the difference. And that will be 10.05 minus 10.00, which will give us 0.05 centimeter. So this is the change in the length. It is the extension produced. I've kept the unit in centimeter without conversion because there is a reason for that. And that reason is that we need to calculate for the strain. So what is the formula for strain? Strain is given as the extension, which is the change in length, divided by the original length. You agree with me that this is in centimeter. The original length is also in centimeter. By taking the ratio, the units are going to cancel out. So strain is unitless. That is why the unit is not under consideration. Now put in values, strain will be equal to 0.05 for the change divided by 10, the original length. And that will be 0.005. So this is the strain. Now we know the strain, let's come back to calculate the stress. So the stress will be 10 raised to power 10, the Young's modulus, which is stress 10 raised to power 10 divided by strain 0.05. If you put this value into your calculator, you are going to obtain 2 times 10 raised to power 12 Newton per meter squared. This is the unit of this Young's modulus because it is simply the unit of stress. Strain has no unit, so it maintains the unit of stress. So the Young's modulus is 2 times 10 raised to power 12 Newton per meter squared. And that is the answer to this question. Very simple, straightforward, and I believe you enjoyed it. I have another simple one for you. If the cross-sectional area of the wire is 1.3 times 10 raised to power minus 7 meters squared, find the stretching force. What is the force that is used to stretch this wire? Please put your answer in the comment section. As a hint, stress is given as the force divided by the area, so you can use the value of stress to calculate for the force. I hope you enjoyed this video. Please like, share, and follow our page if you've not done so. Subscribe to our YouTube channel if you have not subscribed, and I hope to see you in the next video. Thank you.